73 equals, subtract 5x from both sides, and I'll have 3x minus 49. I would add 49 to both sides. That would give me what, 73? No. 72 divided by 3x, so my x would just equal 9. It's not. Yeah. What should it be? Ooh, I'd go with 24. All right, our x is now 24. Are we tracking? We good so far? Okay, so that's 24. Now, here's the thing. Look at the angle I need to find. I need to find that little angle right there, that little dot. Maybe I can put, I don't want to put a y there or anything. But what I want to focus on is this big triangle right here. What happens if I add all the angles of a triangle up? They 180. Now, what I want to point out is if this is 20, we can use alternate interior angles to say that this one is 20 degrees as well. So I now know one of the angles is 20 degrees because of alternate interior angles. I also know an x value. So I'm going to take that x value, I'm going to plug it in here, and this will equal my other angle. Now, if I know two angles, I just have to do 180 minus those two angles, and that will give me my missing angle. Santiago, you asked this one, right? Yeah. Is that far enough, you think, or do you want me to keep going? Yeah. Okay. So the big thing was realizing it was a triangle. We knew one of the angles, and we used the formula to find that other missing angle. Okay, what else we got? Yeah, Max.
12.
12?
Just setting it up.
Are you sure it's 12? I'm only going to go through one of these problems. Are we okay with it being 12? They're all almost the same. So once you know how to do 12, you should be able to do the other ones, okay? Okay, so they give me a bunch of information. They give me PT equals 2x. They give me TR equals y plus 4. They give me QT equals x plus 2. And they give me TS equals y. What do we know about the diagonals of a parallelogram? The diagonals of a parallelogram are not congruent. What do we know about the diagonals of a parallelogram? They bisect each other. So they create congruent segments, but not all of them are congruent. In other words, we could say something like PT is congruent to TR, and we can say QT is congruent to TS. I can't say all four of them are congruent, but I can say their pairs are congruent. That's important because that's going to change today with rectangles. So keep that straight. Okay, so now that I know those things are equal, I can set up two equations. The first one I'm going to set up is, I know 2x has to equal that y plus 4. So one equation is going to be 2x equals that y plus 4. I also have these segments. I have this y equals this x plus 2. So I have y equals x plus 2. Now I have a system of equations. I have two equations, which means I can use substitution to say, okay, y equals x plus 2, so I can plug that in right there, which will give me the new information that 2x is going to equal x plus 2. When I substitute something in, I use parentheses. Plus 4. Now we can reduce stuff down, so I'll have 2x. Now remember, with parentheses, what's technically in front of this? A 1. Does multiplying by 1 change anything? No. So those parentheses just disappear to be x plus 2 plus 4. Let's move that x to this side. That will give me x, subtracting on both sides, equals 6. I know x equals 6. I do not know y. Well, if you know x equals 6, we just plug it in. You can plug it into either one of them, Max, but which one looks easier to plug in to solve for y?
Well, x plus 2.
Probably just this one, because I can just go ahead and plug that in and go, okay, that means y would equal 8. But that will be the same in all of them. All of them you just have to set up correctly, use substitution to solve for it. Okay? All right, other questions? Go. Number 3. Do you have a particular question?
Just the angles. I can get.
Just the angles? Okay, so we have PQR. PQR is 106. So that means that angle PSR is also 106. So I'll go ahead and label that right off the bat. We have QSR. QSR. So that's that little angle here is 49 degrees. Let's cross that out. And we also have PRS. PRS is going to be 35 degrees. So 35 degrees in there. All right. Let's quickly just come up with all of our angles based upon that fact. So what I would do first is I would do the big angles. I'd go, okay, if this is 106 and these have to be supplementary, I'm going to go, oh, this big angle right here has to be 74 degrees. Does that make sense?
Yeah.
Because they have to equal 180, so these would be all 74 degrees. Now I'd go in here and I'd do my alternate interior angle. So if this is 35, that must be 35. If this is 49, this will also have to be 49. Now, to get anything else, we have all the information we need because this angle plus this angle has to equal 74. So I'm looking at, 35 plus that dot has to equal 74. So we'll just do 74 minus that 35. That'll get us that angle. We can use alternate interior angles, which would get me over here. We could do the same thing with this 49 because 49 deals with that 106. So if I do 106 minus 409, I get that angle there. And if they ask for any of the inside angles, remember you do have triangles that sum to 180. So let's say I asked you for, guys, can you just hold off? So let's say I asked for that angle. I would just do 180 minus 49 minus 35. So that will get you every single angle in here. Is that good enough?
Yeah.
All right. Anything else? Okay, then let's go over today's lessons. Make sure earbuds are out. Okay, so today's lesson. What did we cover yesterday? We covered parallelograms. We said a parallelogram has opposite sides that are parallel. So what I'm going to do is I'm actually going to circle this one and say this is the definition of parallelogram. That comes from the definition. Everything else are rules based upon that definition. We said that opposite sides need to be congruent. So if I wanted to make marks on here, I'd go, oh, that would be congruent to that. These would be congruent to that. We also know opposite angles are congruent, so we could make marks like this on all of our angles. Consecutive angles are supplementary, so if we wanted to, we could go ahead and add to our picture that those have to add to 180. And finally, diagonals bisect each other. That means that they create midpoints. Does that mean every segment is congruent? No. So we have to be careful. Like if I use 3 dashes on these two, I need to use 4 dashes on these because the diagonals themselves are not congruent. That right there is a parallelogram and all the rules that go with it. Today we're going to add to our arsenal rectangles. Rectangles are parallelograms. What are rectangles? Parallelograms. Are parallelograms quadrilaterals? Yes. So rectangles also a quadrilateral. So picture this. We got a hierarchy of things. We go quadrilateral becomes a parallelogram as long as sides are opposite. If you have a parallelogram, it might be a rectangle. It might be a rectangle, but it has to meet a couple definitions. Let's go through those real quick. So we have a parallelogram, and now we're going to upscale it to be a rectangle. I already said it's a parallelogram, so all the previous rules apply to it. Opposite sides are congruent, opposite angles are congruent. We have consecutive angles are supplementary, diagonals bisect each other. To be a rectangle, it must be a parallelogram, and it must have a right angle. Now, before I write that down in that box, I'm going to show you this picture. If this is a parallelogram with a right angle, it has to be a rectangle. If this is 90 degrees, what do I know about all the other angles? Santiago?
90 degrees too.
They all have to be 90 degrees too, because opposite angles must be congruent. Consecutive angles have to add up to 180. 90 plus what equals 180? So that would also be 90. So to be a rectangle, all angles must be right angles. All angles must be right. Or 90 degrees. Okay, so that needs to be memorized. As soon as I say rectangle, you have to go 90 degrees. There's also one more rule. We've already said that diagonals bisect each other. That comes from them being parallelograms. But there's something specific about rectangles' diagonals. Anyone want to take a guess at what you think it might be? Yeah.
They're congruent.
They are congruent.
Isn't that the same for?
It is not the same thing as parallelograms. Look at your rules for parallelograms. Does
Yeah, 1 or 4 and 1 6.
Yes, that's why I specifically pointed that out. To be a rectangle, diagonals must be congruent, or diagonals are congruent. And we said they already bisect each other, so if it's a rectangle, I can put the same mark on all 4 of them. All 4 of those segments are, in fact, congruent. So it's not going to be so much on this one, but I want us to start thinking about a specific way. This will show up on a test. This will show up on homeworks later on. You have to be able to give me the most specific definition of what I'm describing as you can. So let's think about this. Can we all look up here? Because this is for future. This is just for knowledge. It's not going to help us in homework. It will help us on future homework. All right. If I told you you have a parallelogram that has diagonals that are congruent, what's the most specific term you could give for that? It would have to be a rectangle. What if I said you had a quadrilateral where opposite sides are parallel? What would be the most specific name you could give that? You could give it a... Could you say it's a rectangle? Does it have to be a rectangle? What did I say? A quadrilateral where opposite sides are parallel. Does that have to be a rectangle? No. What does it have to be? Parallel. That's the furthest I can describe it. What if I'd say you had a quadrilateral, opposite sides are congruent, and you have a 90-degree angle? That could be that would be a rectangle. That would be the most specific name you can have. What if I said you have a quadrilateral that has diagonals? What's the most specific name you could give it? If I say you have a quadrilateral with diagonals, you have 3 options. You can call it a quadrilateral, you can call it a parallelogram, or you can call it a rectangle. Quadrilateral will be as far as you can go because all quadrilaterals have... You got to listen for specific things. And let's pay attention. I see a whole bunch of people writing notes and not even paying attention to what I'm saying. Whatever. You can get those wrong on the test. That's on you. But if you're paying attention, think of the words I'm saying. I said quadrilateral with diagonals. That has nothing to do with the parallelogram. What if I'd say you have a quadrilateral, opposite sides are congruent, and the diagonals bisect each other? It can only be a parallelogram. It might be a rectangle, But parallelogram would be the most specific you can give it. So your job is to understand, to go from a quadrilateral to a parallelogram, you must have parallel lines. To go from a parallelogram to a rectangle, you must have one of these two specific things. So unless you achieve that next level, you have to stay where you're at. So if I say a quadrilateral with diagonals, you can only say it's a quadrilateral. I don't have the parallel lines. If I say you have parallel lines and I don't give you right or diagonals are congruent, you have to stay at parallelogram. So you have to say the right specific things to boost up to the next level. Hope it's just because we're missing people, but wow, that was rough. That was a bit rough. Okay. Let's go through some quick examples. All right, let's go through number one. Number one. Some of these will be easy and they'll get more difficult. Number one, if PQ equals 24, what else do we know? Let's raise our hand because we're kind of low energy. We would also know SR is 24 because opposite sides of a parallelogram, we know a rectangle is a parallelogram, so that would be 24. And we can find SRs right here. If I give you PS equals 10, what else did I give you? Yeah.
QR equals 7.
I also gave you QR equals 10. Here's where we get a step up here. SQ. Do we have anything labeled on our diagonals? Now, let's look at the screen real quick. Let's say I did this. Let's say I put a 3 here. You'd have all the information you'd need because they'd all have to be 3. I did not do that. I didn't give you any diagonal information. Yeah.
I think I may not have did it. It's like a guess.
Okay.
Wait, like if you look at it, it's like a triangle here. I'll have to equal the 180. So like,
We're close. So that'd be with angles.
Say peak S is equal to PT
We're close. That'd be with, you're thinking of angles though. We would have congruent segments, so if I could find one of them, we could do all of them. But it's not this triangle I'm looking at. There's another triangle that's a better triangle to look at. So, like I said, this is not the key to solving this. Because all this would give me is that both of those would be the same. That would not be the triangle I'm looking at. Joseph? We don't have a 30, 60, 90. But we do have a
PRQ triangle.
we have a PRQ triangle.
Can you just do A squared plus B squared?
We're going to do A squared plus B squared equals C squared because I don't know any of the angles. You can't call it a 30, 60, 90. You cannot call it a 45, 45, 90. I don't care how much it looks like that. This is just a right triangle where you know 2 of the sides. So if I pull this out, this is just a right triangle where I know the 2 sides. I know this 10, I know this 24, and so we can use A squared plus B squared equals C squared. Can someone remind me, so I have A squared plus B squared equals C squared. Which one of those 3 letters would be my hypotenuse?
C squared.
C would be my hypotenuse. So I could go ahead and call this my C. So we would do 10 squared plus 24 squared equals C squared.
100.
I would go ahead and just plug in my calculator. I don't know about you guys. I know some of you like to take the whole time, but you might also run out of time on a test. I would just do 10 squared plus 24 squared. What does that equal? 6.
636. Well, no, but I was just doing
676? I would not piecemeal that. I would just plug in 10 squared plus 24 squared. Now, we know this is going to be C equals the square root of this. Now, pay attention with me because your homework's going to change. Some of you are going to make this really hard because you're not going to pay attention to me. What do the directions say?
years 10.
So you will always be plugging this in your calculator. Even if it comes out to decimal, we won't have to simplify it like we did on the previous test. We'll just plug it in our calculator. Turns out this one is already a perfect square, right?
It's 26.
It just equals 26. But let's just pretend it didn't. This does equal 26, but if it equaled 26.2, we'd put 26.2. We would not simplify it how we were doing it on the test. So these will all be plugged in, and getting decimal approximations, but this would just be 26. So SQ equals 26. What does that mean about PR? It is also 26 because diagonals are congruent in a rectangle. Diagonals are congruent in a rectangle. What would QT be then? It'd be 13 because it'd be half a diagonal. So SQPR, congruent because they're diagonals. This is half our diagonal, so it would just be 13. I think I wrote 12 for some reason. It should be 13. All right, questions? Xavier, you got a question? Okay. All right, let's continue on. Let's go to number 3. Number 3 is a key fact that we need to know about rectangles. If I give you any angle of rectangle minus the 90-degree one, you can find all of them. Let's go through it and see how we can find all of them. The first thing I'm going to look at is at 27 degrees. Does anyone see another angle that has to be 27 degrees? Joseph?
KLN.
KLN.
NLM.
NLM, that I would agree with. So NLM would be congruent to 27 because what kind of angles are those? Those are alternate interiors, so this would be 27 degrees. Yeah. JKM is also 27 degrees. Why is that one? They're all congruent, so what triangle does that form? That forms an isosceles triangle. Let's pay attention to that. That's really important. Let's not work on another problem because this is an important thing that a lot of you are going to mess up on. A rectangle has isosceles triangles built into it. What do we know about the base angles of an isosceles triangle? They're both congruent. So this is an isosceles triangle. And so our base angles are congruent. What does that mean about NML? It's 27 as well. All right, how do I get those other missing angles? Yeah.
Subtract 27 by 90.
27, because all these are 90 degrees. If all of these are 90 degrees, to find a missing one, any one of these, I'm just going to go, oh, that's just 90 minus 27, which is going to be, what, 63 degrees? And then I can label all the rest of them 63 because we can use alternate interior angles to get here. We can use isosceles triangles to get the rest of them. Now, let's go one step further. I said we can find all of those angles based upon that 27. How do we get to these middle ones? What was that? Which ones?
63 and 63.
So we could do, yep. So we can do 63 plus 63, subtract that from 180, and we will have this measure here. So we do 63 plus 63 minus 180. So let's just put that off to the side. I'll do 180 minus 63 minus 63. What is the measure of that angle? 54 degrees.
3 plus 3 is 6, 6 plus 6 is 12.
All right, that's 54 degrees. How do I know the one across from it is also 54 degrees? Vertical angles. How do I get this angle right here? There's two ways. Describe one way I can get this one. There'd be supplementary angles, so I can do 180 minus 54. I could also treat it as a triangle again and do 180 minus 27 minus 27, which will get that either way. So that angle right there is going to be 126 degrees. Vertical angles go across, and we have that one as well. I have all of them labeled. You figure out which one goes where. Yes?
126 is supplemented at which angle?
Or
He also says supplemented to 27.
Or it's 27 plus 27 plus 126 equal 180. All right, questions on that? Okay, let's do a couple more. That's too easy. Too easy. Too easy. We're going to go ahead and we're going to do number 9. All right, guys, I need you to focus. Number 9. Number 9 gives me 5x plus 7 equals that angle. And it also gives me 134 degrees up there. How does that 134 help me with the 5x plus 7? Or what could something we could do? Yeah. We could do alternate interior. So wouldn't that just make this one up here 5x plus 7? I don't think that helps us with the 34. We can leave it up there. It's right. I agree. That's something we could try to do, but I don't think it helps me. That 134 is still kind of locked away from where I'm trying to look. Grant, what do you think? We could find the supplementary angle. So you're talking about this angle right here, right? What would the measure of that angle be? We'd have 46 degrees. Oh boy, what do we know about angle HDG and DGH?
Oh wait, DDH you said?
They are.
Yeah.
They're congruent. Both of those angles are in fact congruent. What does that do for me? I have 46 degrees and I have two congruent angles. Say that one more time.
Do 5x plus 7 divided times 5x plus 7.
Probably not times.
Or equals.
Not squared. We could set it equal to 1/8. Hey guys, I hear multiplication happening. When you add angles together, do you ever multiply them? You add them, right? So if I'm going to add angles, angle plus angle equals 180. So one way we could do this is just one way we could do this. We could do the 5x plus 7 plus 5x plus 7, because that's both my angles added together, plus that 46 degrees equals 180 degrees. This is one way to do it. Angle plus angle equals 180.
Combine like this and that.
We're going to do that, yes. So we know that both of these would be 5x plus 7. So angle plus angle equals 180 because the triangle equals 180 degrees. Combining like terms, I would do that 5x plus that 5x to give me 10x. I would do that 7 plus 7, which is 14, plus that 46, which is going to equal 60. So we have plus 60 equals 180. We will subtract 60 on both sides. We'll have 10x equals 120. I subtracted 60. You subtract 60 from both sides, divide both sides by 10, and we'll have x equals 12. And in fact, that's all I needed to do because it said just solve for x. Does anyone see another way to do this problem? Yeah.
So angle HDE is congruent to HED. So you do 2x or 134 plus 2x equals 180. I'll give you the angles for both of them.
Mm-hmm.
Get since angle H
Yeah. I'm going to make that just a little simpler on us. Same idea, though. So, if I give you one angle, you know the measures of the other angles in an isosceles triangle. If I tell you this is 46, you can find the other ones by doing 46, 180 minus 46, which is going to equal 134. And if I take 134 divided by 2, these are going to be 77 degrees. So you could have, one nice shortcut is you could just put 5x plus 7 equals 77 degrees. Then you would have got there with your logic of going through it. But that could be an easier method. I know a lot of us didn't write that down, which is frustrating. But you do you. If you want just one method and hope you get it, that's on you. All right. Any questions on the ones we just covered? Yeah. Why did it equal 134 on my alternate way? My alternate way is basically, let's say I asked you for the measures of these two angles, and we know they're both the same. We know that a triangle equals 180 degrees. So if I do 180 minus 46, I have 134 degrees to split between these last two. And since they're equal to each other, I can just divide by 2, which will give me each one of these must be 77 degrees, because that means 77 plus 46 equals 180. And since we know 5x plus 7 occupies the same space as 77, we can say 5x plus 7 equals that 77. We'll come up with the exact same answer. Okay? All right. The rest of them are yours. You need to start at number 10 and work your way backwards. I don't want to watch you struggle through a really easy problem just to waste time. We're going to start at 10. You're going to check it off. I would like you to work as a group, but I'm not going to force it this time. If you just want to work on your own and get ahead because you've been taking notes and you know this stuff, you can fire through it. Always a good idea to help someone else out.